Hi, today we are going to see problems related with Biot Savart Law, and we have two applications in that. Biot Savart Law basically gives us the information the wire is carrying a current or current passing through the wire. What is the magnetic field in the nearby area? That is given by Biot Savart Law. So simple. So we have a wire carrying a current I. What is the magnetic field at the point P outside? That is Biot Savart Law. You consider a small element CD, join this through a distance R, which makes an angle theta. Entire wire you are not considering, you are taking a small part of the wire. From the wire, you join a line at a distance R to the point P. Then magnetic field of induction at the point P is proportional to current element. The element length is dl, IDL, current element, proportional to sine of the angle between the element and line joining, and inversely proportional to the square of the distance. dB proportional to IDL sine theta by R square, or dB is equal to a constant K IDL sine theta by R square. dB vector is equal to mu naught by 4 pi is the K value. IDL vector cross R cap by R square, because sine theta is nothing but vector product. So vector product here is IDL vector cross R cap by R square. No sir, I want to put R vector here. No problem, you can put. So this will be changing to R cube. Because when you expand this, you will get IDL R sine theta by R cube. IDL sine theta, IDL R sine theta by R cube. So when R get cancelled, you are getting this answer. Okay, so this is Biot Savart law. Current due to the small wire. Considering the small element in the wire, what is the magnetic field we have seen? Here we have two applications. First application, magnetic field at a point due to infinitely long charged wire or infinitely long straight conductor carrying current. Center O, you are considering a point P. Our aim is to calculate magnetic field at the point P, which is at some distance. As usual, take a small element CD, join. The magnetic field produced here is away and perpendicular to the plane. This is the current carrying conductor, means magnetic field will be perpendicular to the plane. dB. Or OP distance. Infinitely long. So we have put a dotted line here. This is phi. This is d phi. This angle is phi 1. This angle is phi 2. First you calculate current due to the small element CD. What is the magnetic field dB? Then you extend for the entire conductor. The final formula for magnetic field of induction or magnetic flux density is B is equal to mu naught I by 2 pi D. Now, sir, this distance I will take it as R. R already we have taken, so 2 pi A, 2 pi A, whatever may be. From the center to the point B, what is the distance that should be taken? This is for infinitely long straight conductor carrying current. Actual formula is mu naught I by 4 pi A sin phi 1 plus sin phi 2. Infinitely long straight conductor means phi 1 and phi 2 approximately 90 degree. So, sin 90 plus sin 90, 1 plus 1, 2. 2 and 4, 4 pi cancels, you are getting mu naught I by 2 pi A. This is for infinitely long straight conductor carrying current, the magnetic field at a given point. Good. Next, for circular coil carrying current. Circular coil means this is a circular coil carrying a current I. Our aim is to calculate magnetic field at the point P due to the circular coil. Join. Magnetic field is away and perpendicular dB. For this side, away and perpendicular dB. Since it is not exactly in horizontal or exactly in vertical, you have to resolve it into components. This is phi. So, this is 90 minus phi, this is phi. Similarly, 90 minus phi, this is phi. Resolve dB cos phi, dB sin phi. dB cos phi, dB like that. You are dividing this entire coil into so many small elements. Radius R, the distance from O to P is A. Magnetic field at the point P due to the circular coil carrying current is given by the formula B is equal to mu naught I A square R square by 2 into R square plus A square whole power 3 by 2. This is the final formula for magnetic field of induction due to circular coil carrying current. The distant point, which is at a distance of A. No, sir. Keep this point P at the center. At the center, A becomes 0. So what will you get? B is equal to mu naught I R square. 2 into this is 0 R square power 3 by 2 is R cube. So 1 R square and R cube cancels. You will get mu naught I by 2R. This is the magnetic induction due to the circular coil at any point outside. At the center is mu naught I by 2R. Like that you have n turn coil. One turn means okay, this is n turn coil. N turn means what is the meaning? B is equal to, for n turns, B is equal to mu naught Ni by 2R. Capital N or small n, anything can put number of turns. This is Biot Savart Law, second application. So keep this Biot Savart Law and its application. We'll work out some problems. First problem, a current of 10 ampere is flowing in a long wire kept horizontally in the east-west direction. East-west direction, you are keeping the wire. east, west. Current is passing through. Find the magnetic field in horizontal plane at a distance of 10 centimeter north, 20 centimeter from the south, 20 centimeter south from the wire, 10 centimeter north, 20 centimeter south. Calculate the magnetic field. Infinitely long charged wire only, but in the vertical, horizontal they have given. That's all. Same formula. B is equal to mu naught I by 2 pi r. First case, B north. What are the data given? Current is 10 ampere. Distance is 10 centimeter. Mu naught is 4 pi into 10 power minus 7. Current given as 10 ampere. Distance is 10 centimeter. 10 centimeter means 0.1 meter. Cancels. 0.1 is 1 by 10. So numerator 100. 2 into 10 power minus 5 Tesla north. Next, for south, distance is 20 centimeter. Same concept. Ds is mu naught I by 2 pi r dash or r1. 4 pi into 10 power minus 7 into 4. No, current is 10 ampere by 2 pi into 0.2. Here 10 centimeter, here 20 centimeter. So I can write B south is equal to 2. 2 into 0.2. 2 into 10 power minus 1. 4. 4 pi cancels. 2 into 10 power minus 1 will go to 10. 10 power minus 7, 10 power 2. 1 into 10 power minus 5 Tesla. This is for south direction. Next, 40 centimeter downward and 50 centimeter upward. Same formula. 40 centimeter downward. 50 centimeter upward. Mu naught I, that is 4 pi into 10 power minus 7 into 10 by 2 pi into, what is the value given for down and up? 40 centimeter downwards and 50 centimeter upwards. Point 4. This is 4 pi into 10 power minus 7. 10 by 2 pi 0.5 meter. Centimeter means 0.5. Depending upon right hand thumb rule, direction of current, direction of magnetic field. Depending upon that, you will get the result. Southwards, northwards. So, pointing into the plane, pointing out of the plane. This is current direction, this is magnetic field direction. You can easily calculate using this right hand thumb rule principle. What is the direction? Going into the plane, going out of the plane. This is clockwise, north, upwards, south, downwards. Correct? This is first problem. Second, a straight wire carries a current of 3 ampere. Calculate the magnitude of magnetic field at a point 10 centimeter away from the wire. This is the wire carrying a current I at a distance of 10 centimeter. What is the magnetic field? 10 centimeter. What is the current given? 3 ampere current. So this is infinitely long state conductor. Same formula. B is equal to mu naught I by 2 pi r. 4 pi into 10 power minus 7. Current 3 ampere by 2 pi into r distance is 0.1. 2 pi, 4 pi, 6 times, 2 times. 6, this is 1 by 10. 6 into 10 power minus 6 Tesla. Straight problem. Okay. This is second one. Third problem. What distance from a long straight wire carrying a current of 12 ampere will the magnetic field be equal to 3 into 10 power minus 5 Weber per meter square? Current 12 ampere, magnetic field 3 into 10 power minus 5. You have to calculate the distance. B is equal to mu naught I by 2 pi r. R is equal to mu naught I by 2 pi b. 4 pi into 10 power minus 7. What is the current given here? 12 ampere. 12 ampere current by 2 pi into 3 into 10 power minus 5 Tesla. Simplify, you will get this is 2 times, this is 4 times 8 into 10 power minus 7 plus 5. 8 centimeter or 8 into 10 power minus 2 meter. Same formula, different concept we are studying. Distances, sometimes we may ask to calculate current, sometimes what is the magnetic field. 3 quantities will be repeated. Next, fourth problem. A long straight wire carrying a current of 30 ampere is placed in an external uniform magnetic field of 4 into 10 power minus 4 Tesla parallel to the current carrying conductor. Find the magnitude of resultant magnetic field at a point 2 centimeter away from the wire. Magnetic field given, current given, distance given. Actually placed perpendicular to the magnetic field. So the magnetic field you have to calculate using the basic formula. Another one is a perpendicular magnetic field given. So B1 you have to calculate, B2 given, calculate the result. B1 mu naught I by 2 pi r. 4 pi into 10 power minus 7 into the current 30 ampere, distance 2 centimeter away, 30 ampere by 2 pi into 5. So B1 is equal to 2 times 2 and 0.2 is 10, 60, 300, 10, 300. So 3 into 10 power 2, 10 power minus 7. So 3 into 10 power minus 5. Given another magnetic field, B2, 4 into 10 power minus 5 Tesla. So resultant B1, B2, this is root of B1 square plus B2 square. So B will be root of 3 into 10 power minus 5 the whole square plus 4 into 10 power minus 5 the whole square. 3 square 9, 4 square 16 plus 9 is 25, root 25 is 5. 5 Tesla is the result. Okay, next. Fifth problem. What current must flow in an infinitely long straight conductor to give a flux density of 3 into 10 power minus 5 Tesla at 6 centimeter from the wire? Magnetic induction 3 into 10 power minus 5. Next, what are the data given? At a distance 6 centimeter from the wire, R is equal to 6 centimeter. What you have to calculate? Calculate the current. B is equal to mu naught I by 2 pi R. B into 2 pi R by mu naught. What is B given? Magnetic field 3 into 10 power minus 5 Tesla. B is 3 into 10 power minus 5. 2 pi into R is 6 into 10 power minus 2 by 4 pi into 10 power minus 7. So 2 times here. 18 by 2 is 9. 10 power minus 7 minus 7 cancels. 9 ampere. 9 ampere is the answer. Straight problem. Same current conducting wire, I, magnetic field at this point is given, which is a distance of A. You are required to calculate this small portion magnetic field. That is B is equal to mu naught I by 2 pi R. From that, B you are calculating. That B is given in the problem. You have to calculate what current is passing. Okay. Sixth problem. Two long parallel wires are placed at a distance of 16 centimeter from each other in air. Each wire has a current of 4 ampere. Calculate the magnetic field at midpoint between them when the currents in them are in the same direction, in opposite direction. Current in the same direction means using Fleming's left-hand rule. When you calculate the force, that force is away and perpendicular. Whenever a current carrying conductor is placed in the magnetic field, there exists a force. Two parallel conductors carrying current in the same direction means it will get attracted. That is for force. Magnetic field, same direction. B1 minus B2 is. Okay. Next. Current moving in opposite direction. B is equal to B1 plus B2. That is 2B. So B1 mu naught I by 2 pi R. 4 pi into 10 power minus 7. What is the current given? 4 ampere. Distance is 16 centimeter. 4 pi into 10 power minus 7. 2 pi into, what is the distance given, man? 16 centimeter. Current is 4 ampere. 16 centimeter is 0.16. 2 pi and 4 pi 2 times. This is 16 into 10 power minus 2. Correct. 2 into 4, 8 by 16. That is 0.5 10 power minus 5 Tesla. Here, same direction, so 0. Opposite direction means it is 2B. So, along south or B2, generally can write. B is equal to B1, 0.5 into 10 power minus 5 plus 0.5 into 10 power minus 5. 0.5 plus 0.5 is 1. So 10 power minus 5 Tesla. Correct, Amma? Same problem. But current moving in opposite direction. Same direction. Force means it will attract. The magnetic field means it is moving in opposite direction. Direction of magnetic field is away. Opposite direction, so minus sign. Okay, next. Seventh problem. A long straight telephone cable contains 6 wires, each carrying a current of 0.5 ampere. The distance between the wire is negligible. It is very close. What is the magnitude of magnetic field at a distance of 10 centimeter from the cable? If the current in all 6 wires in same direction, 4 wires carry in one direction, another 2 in opposite direction. Here also magnetic field only you have to calculate. This is a cable. In that 6 wires, distance between the wires is negligible in the condition given. The entire cable, this is a cable. Here you have a pointer. This distance is given 10 centimeter. What is the magnetic field at this point B? Due to all the 6 wires carrying current in same direction. Current in same direction. Same direction means what? Net current first we calculate. Net current is equal to number of wires into current in each wire. What is number of wires? 6 wires. Current given as 6 ampere. No, 0.5 ampere current. 0.5. 6 into 0.5, 1 by 2, that is 3 ampere. So B1 is equal to mu naught I by 2 pi r. 4 pi into 10 power minus 7. Current here is 3 ampere by 2 pi into r is 10 centimeter. That is 0.1. 2 times. 2 into 3, 6. 0.1 is 1 by 10. So it will become minus 6 Tesla. Straight. 6 wires carrying current in the same direction. This is the magnetic field. 4 wires in one particular direction. 2 wires carrying current in opposite direction. Second case. So net current is what? Say this, you take it as B1, no problem. I dash N into I1. 4 wires carrying current in the same direction. 4 into 0.5 minus, why minus? two wires carrying current in opposite direction. So 2 into 0.5. 4 into 0.5 is 2. 2 into 0.5 is 1. So 1 I dash. Therefore, B2 is equal to mu naught I dash by 2 pi r. 4 pi into 10 power minus 7. What is I dash ma? 1 ampere by 2 pi into 0.1. That is 10 centimeter or 0.1 meter. Say substitute. 2 times. 2 into 0.1 is 1 by 10. 10 power minus 6. 6 into 10 power minus 6. That is 2 into 10 power minus 6. Okay. Eighth problem. The plane of a circular coil is horizontal. It has 10 turns, each of radius 8 centimeter. Current of 2 ampere flows through it. The current appears to flow clockwise from the point above the coil. Find the magnitude and direction at the center of the coil. Magnetic direction of B. Magnetic field we have to calculate. Magnitude and direction of B. Circular coil carrying current. Basic formula B is equal to mu naught N R square. N I R square. 2 into R square plus A square whole power 3 by 2. Okay. So B is equal. At the center of the coil, R is the radius. A is the distance from the center to the point P. Question is, what is the magnetic field at the center? Center itself it is asked. That is the principle of tangent galvanometer. Here A is equal to 0. A is the distance between the center and the point P. Now point P is at the center itself. So A is equal to 0. R square R cube cancels, mu naught Ni by 2R. Now state substitution. What is the value? Mu naught Ni by 2R. Current is 2 ampere. Number of turns 10. Radius is 8 centimeter. 4 pi into 10 power minus 7 into number of turns 10. 2 ampere by 2 into what is the distance given? 8 centimeter. 0.08 meter. 2 cancels. 8 into 10 power minus 2. Numerator plus 2. 10 power minus 5. This is 1 0. 10 power minus 4. Then what else? 5. 4 and 8 is 2 times. Denominator 2. 5 by 2. 3.14 by 2. That is 1.57 into 10 power minus 4 Tesla. Correct? Straight formula. Circles along the axis. Suppose that it is placed at a distance of this formula we have to use. Question here is point at the center. So we have taken x is equal to 0. Point is at somewhere means according to you substitute the value. A value can substitute. Next, ninth problem. In the Bohr model of hydrogen atom, an electron revolves around the nucleus in a circular orbit of radius 5.11 into 10 power minus 11 meter at a frequency of 6.8 into 10 power 15 hertz. What is the magnetic field setup at the center of the orbit? Same formula, but here current directly not given. B is equal to mu naught I by 2R. Mu naught Ni by 2R. Particular orbit given. So R is equal to same formula. B is equal to mu naught I by 2R. I, N is 1. Same orbit. So N is equal to 1. R also given. But I directly not given. What is I? Charge by time. That is Ne by T. 1 by T is nothing but frequency. Number of oscillations per second. Here number of vibrations per second. Number of cycles per second. Anything you can write. 1 by T we call it as frequency. That is F. Number of electron 1. E is 1.6 10 power minus 19. What is frequency given? 6.8 into 10 power 15. Into 1.6 10 power minus 19. 6.8 into 1.6 10 power 15 minus 19 is 10 power minus 4. This is current. Therefore, B is equal to 4 pi into 10 power minus 7. Current 6.8, 1.6, 10 power minus 4 by 2R. What is the distance given? Distance is nothing but radius 5.11 into 10 power minus 11. Straight problem, but the data you have to substitute what is given here. So simplify 13.4 Tesla. Minus 7 minus 4 is minus 11. Minus 11 minus 11 cancels. 4 pi into 2. So 2 pi. 2 pi into 6.8 into 1.6. Multiply with the answer divide by 5.1. You are getting the answer 13.4 Tesla. Okay. Next, 10th problem. The radius of first orbit of hydrogen atom is 0.5 Armstrong unit. Radius is 0.5. R is 0.5 Armstrong. The electron moves in an orbit with a uniform speed of 2.2 into 10 power 6. Velocity 2.2 into 10 power 6 meter per second. Calculate equivalent current, equivalent dipole moment, magnetic field produced at the center of the nucleus due to the motion of the electron. Calculate the equivalent current. First we have to calculate. Current I is equal to charge by time. That is Q by T. Ne by T. T we have to calculate. T is 2 pi by omega. Omega is P by R. 2 pi into R is what? 0.5 Armstrong unit. Armstrong unit means what, ma? 10 power minus 10 by velocity 2.2 into 10 power 6. 2 into 0.5 is 1. So pi is 3.14 by 2.2. Simplify. Or 22 by 7 you can keep. 22 by 7 you can simplify. So you are getting 1 by 7 into 10 power minus 15 seconds. 1 by 7, 10 power minus 15. 1 by 7, if you want, you can simplify. Otherwise, leave it as it is. No problem. Equivalent dipole moment. Time but only a calculated. Current you have to calculate. I is equal to Q is NE. N here is 1. So Q is equal to E. An electron. See the question. One electron only. So I can write 1.6 10 power minus 19 by T. T is 1 by 7 into 10 power minus 15. 111.2 into 10 power minus 30. Q by T only, no? 10 power minus 15 will be in denominator. 1 by 7, that 7 alone will go to numerator. Ma. So, minus 19 plus 15 is 10 power minus 4 ampere. Next, magnetic field produced at the center. What is the formula for magnetic field at the center? Third. Second, magnetic field at the center. Equivalent dipole moment. Dipole moment basic formula is current into area. Magnetic dipole moment. Small m is current into area. What is current? 11.2 or 1.12 10 power minus 3. 11.2 10 power minus 4. 1.12 10 power minus 3. Both are same. Into pi r square. R square. R is the distance. 0.5 into 10 power minus 10 the whole square. 1.12 into pi. 0.5 square is 0.25. 10 power minus 3 minus 10 the whole square is minus 20. So minus 23. Simplify. And finally, magnetic induction. B is equal to mu naught Ni by 2R. 4 pi into 10 power minus 7. Number of turns 1. Current given as 11.2 into 10 power minus 4 by 2 into R value 0.5 into 10 power minus 10. Substitute and calculate. Final answer is 14.07 Henry or Tesla. Correct, Amma? So these are the problems related with Biot Savart Law. Biot Savart Law, we have two applications. Infinitely long state conductor carrying current. Another circular coil carrying current. Circular coil carrying current point at the extreme, point at the center. There itself we have two cases. Okay, so these are the basic problems related with Biot Savart Law. Thank you. We'll continue.